Okay, so Assalamualaikum warahmatullahi wabarakatuh. Good evening. It's 9:03 now. So I should wait for another 1 minute and then we are going to start. So saya tunggu seminit lah. In case ada yang tak masuk lagi kan. Can you guys hear me clearly? Semua orang boleh dengar ke? Boleh dengar jelas tak? Good evening. Can you hear me clearly? Okay kot Macam tak ni. Clear. Okay. So hari ni kita ada girls je. So girls daripada Aisyah and Farah. Hi Aisyah and Farah. So hari ni girls je kan, girls day. So hari ni kita meriah sikit lah, semua girls je. Including me of course. Okay, so now let us start. So this is the last lecture for chapter 3. So next week we are going to start with a new chapter, chapter 4. So for next week, you guys getting ready for lecture on Sunday, Monday and Tuesday. So we will have 3 hours lecture for next week because I need to do some catch up with chapter 4. We need to be a little bit fast because you have to submit your individual assignment later on. Okay, never mind. Lecture 3. Okay, so this is still sequences and series. So we are at binomial expansion. So we are going to continue from the last lecture. Okay, so at the end of the lesson, you should be able to determine the general term in a binomial expansion, a plus b to the power of n when n is a positive integer, and then determine the expansion of 1 plus x to the power of n for modulus of x less than 1, where n is a rational number. Okay, so next. Right, so this is the formula that we have looked at in the previous lecture. So we have a plus b to the power of n. So this is nc0, a to the power of n, b0, nc1, a n minus 1, b1, nc2, a n minus 2, b square plus dot dot dot, ncr, a n minus r, br plus dot 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 until we have reached the last term, which is ncn a0 b to the power of n. Okay, so what do we call this? So that is actually the first term. And then the second one, n1, that is actually the second term. And then the next one will be the third term. So now, if we have nr, that is actually the tr plus 1 or the r plus 1 term. Okay, so the r plus 1 term of the binomial expansion of a plus b to the power of n. So the formula is tr plus 1 equal to ncr, a n minus r, b to the power of r. Right, so basically the formula that I teach you in the last lecture, where if we have a plus b to the power of n, so this is when we want to expand everything. So that means if you have a plus b to the power of 5, so I want to expand all the terms. So that means 6 terms because we have 5 over here. So I want to get all the 6 terms. So I'm using this formula. But when I'm using the term r plus 1, that means I want to find a specific formula, a specific term, sorry. So for example, if let's say I have a plus b to the power of 5, I simply want to find out what is the coefficient of a cube or a square. So in that case, I'm going to use this formula when we want to find some specific term. Okay, so for the binomial expansion of a plus b to the power of 8, so the third term, so this is T3, the third term. So if you refer to the formula, TR plus 1, this is NCR, AN minus R, B to the power of R. So that means for the third term, T3, so if you compare over here, your R should be equal to 2 because 3 is equal to R plus 1. That means R must be equal to 2. So whenever we see R, we have to substitute them with 2. So we are going to get 8C2, a to the power of 8 minus 2, so a to the power of 6, and then b to the power of 2 or b squared. And then of course you should use your calculator, find out what is this number, 8C2. So by using our calculator, that is actually 28, a to the power of 6, and then b squared. So this is the third term. Okay, so the next one. If let's say we want to find the sixth term, so this is T6 because sixth term, T6. So if you refer to here, TR plus 1, so if you compare them, you should be able to see that the value of R should be equal to 5. So substitute into the formula, it should be 8C5, a to the power of 8 minus 5, so that is why we have a cubed. And then b to the power of r, so b to the power of 5, and then simply use the calculator for 8C5. So that is actually 56, a cubed, b to the power of 5. So this is how, if we want to find some specific term. So instead of expanding the whole thing and getting something very long, so we simply want to find the third term and the sixth term. So we are using the formula for TR plus 1. Okay, so now the first example. Find the coefficient of y to the power of 5 and x to the power of 6 in the expansion of x plus y to the power of 9. Okay, so now let us compare with the formula first. So let us compare with a plus b to the power of n. So if you compare them, you should be able to see this is n, this is 9. Therefore, n is equal to 9 and a is actually x, b is y. So a is x, b is y, and n is 9. Okay, so let us substitute into the formula. Okay, so TR plus 1, that is NCR, a to the power of n minus r, b to the power of r. So substitute, n is 9. So we are going to get 9 CR, and then x, because this is a, so x to the power of 9 minus r, and then y to the power of r. Okay, so now let us compare. So we want to find the coefficient of y to the power of 5. So we want to find the coefficient of y to the power of 5. Let us compare with here. So I have y to the power of r. So compare them with y to the power of 5. We should be able to see that the value of r should be equal to 5. So once you know that the value of r is 5, substitute back into the equation. So we are going to get d, 5 plus 1 equal to 9c5, x to the power of 9 minus 5, y to the power of 5. Simplify them a little bit. 9c5, you can actually simplify them. So it will become 126, x to the power of 4, y to the power of 5. Okay, so if you read the question very carefully, we said that find the coefficient. Find the coefficient. So this is actually terms. This is not coefficient yet. So I simply want the coefficient of y to the power of 5. So other than y to the power of 5, we will have 1 to 6 x to the power of 4. So that means this is actually the coefficient of y to the power of 5. So the coefficient of y to the power of 5 is 126 x to the power of 4. Okay, so now basically I'll give you around 3 minutes. Will that be enough? I'll give you around 2 minutes for you to find out what is the coefficient for x to the power of 6. So I have done y to the power of 5. So I'll give you around 3 minutes for you to calculate what is the coefficient for x to the power of 6. So 3 minutes starting from now. If you have the answer, you can actually write down over there. Fatha dengan Aisyah ada 2 orang kan? Mesti dapat jawapan. Oh, dah dapat dah jawapan. Wait Ayi, we have another 55 seconds to go. So kita bagi masa orang lain buat juga. Oh, WM dah dapat. Ikin pun dapat yang sama. Oh, kejut kan. Okay, so now let us check. Are we going to get the same answer or not? Okay, so now this is what we have previously. So 9cr, x to the power of 9 minus r, y to the power of r. Okay, so we are going to compare for the x. So x to the power of 9 minus r is x to the power of 6. So when you compare the index, you are going to see that r is equal to 3. So go back and substitute r is equal to 3. And then you are going to get d r plus 1. So 3 plus 1 and cr, so 9c3. X to the power of 9 minus 3, y to the power of 3. So the fourth term or T4 is 84, x to the power of 6, y to the power of 3. So now we want the coefficient of x to the power of 6. So that means 84y cube. So 1, 2, 3, 4. So 4 dah betul lah sampai Hafizah. So boleh buat macam ni lah. 4 orang. Siapa betul? Tanya. Okay, so now let us go to example 2. So we have to determine the terms independent of x in the following binomial expansion of x plus 1 over x to the power of 8. Okay, so firstly, let us check what is a, what is b, and what is n, because we have to substitute everything into the formula. Okay, so now compare with a plus b to the power of n. So we should be able to see that a is actually equal to x. So this is a, x. So b is 1 over x. Or you can actually bring it up. So 1 over x is actually x to the power of -1. So I do find that if I have x in the denominator, it will be much more easier if I bring them up, so that when we apply the power, I can easily multiply the index. So this is a hint over here. If you have some fraction, do remember to bring the x up, and then don't forget to put negative. Okay, so that is for b. How about the n? So you can actually see the n is the power. So n is actually equal to 8 as well. Oh, Fatah dah bagi jawapan. Betul Fatah? Boleh buat macam ni. Okay. So now let us substitute into the formula. So TR plus 1 is NCR. So 8CR. And then we have x to the power of 8 minus r. And then of course we got b. B is x to the power of -1 to the power of r. Okay, so this one, I can actually simplify them using the rules of indices, where if we have x to the power of -1 to the power of r, so this one I can actually multiply the index to become x to the power of -r. And then as you can see, this is x, this is also x. So I have something with a common base. So we have a common base over there. So we have x to the power of 8 minus r, x to the power of -r. So if we have a multiplication between the same base, so I can actually add the index. So it will become 8cr, and then x to the power of 8 minus with 2r. So 8 minus 2r, because we have 8 minus r minus r. So minus 2r there. Okay, so now let us see. We want something to be independent of x. So to be independent of x, it simply means that x must be to the power of 0. So sometimes we might call them as a constant term. So constant term or independent of x, they mean similar thing. Both of them simply means that we should have x to the power of 0. So you will compare x to the power of 0 over here with x to the power of 8 minus 2r. So do find out what is the value of r. Okay, so compare them, compare the index. We should be able to see 8 minus 2r is equal to 0. So that means r must be equal to 4. So substitute with r equal to 4. So you are going to get D, 4 plus 1, 8CR, so 8C4, and then of course x to the power of 0. So simply use the calculator. So the term independent of x is the fifth term, which is actually equal to 70. So that is the term independent of x, 70. Okay. So now, basically, what we have done so far is we have solved for a plus b to the power of n, where n is only the positive integers, or we can use a natural number. So n is actually a natural number or a positive integer. So now what happened if n is not a positive integer? What happened if n is a fraction, or perhaps n will be a negative number? So if we have n as a fraction or a negative number, we actually have another formula for that. So we have two formula for binomial expansion. The first one is for a plus b to the power of n, and the second one is the one that I'm going to teach you. Okay, so for binomial expansion, 1 plus x to the power of n, where n is actually a rational number, especially negative integer or a fraction. We use the following expansion. So n will be a rational number where mostly we are going to use them for negative integer or a fraction. Then we use the following expansion. So we are going to use this formula. If we have 1, so for this formula, it is very crucial to have 1 over here. If you don't have 1, that means you should factorize them. For example, if let's say I give you 4 plus x to the power of half. So in order to use this formula, the first number should be 1. So let us factorize the 4 first. So we are going to have 1 plus with x over 4. And then everything to the power of half. So simply factorize the number out first. And then 1 plus x over 4 to the power of half. And then apply the power for each of them. So this is 4 to the power of half. And then 1 plus x over 4 to the power of half. 4 to the power of half is simply 2. So we got 2, 1 plus x over 4 to the power of half. So now we can actually expand 1 plus x over 4 to the power of half using this formula because the first digit is already 1. So do make sure if you want to use this formula, it is very crucial that the first one should be 1. The first number. We should have 1 plus something or 1 minus something. If you have any number, do make sure to factorize them. Okay, so now the formula. 1 plus ax to the power of n. So n is the power. So it will become 1. So 1 is actually the first term. The first term is definitely 1. You cannot change that. So 1 plus. So take the power n. And then you times with ax. So n times ax. And then plus. So this is the second term plus. So this is the third term. And so simply take the power and then minus 1. So n times with n minus 1. You got 2n, right? So divide by 2 factorial. And then take ax, but now you got to have square. And then plus n minus 1, n minus 2, so triple n, so 3 factorial. And then ax to the power of 3. And if you want to proceed, it should be n minus 1, n minus 2, n minus 3 over 4 factorial, and then ax to the power of 4. Okay, so now, by the way, if you didn't know where to find the factorial is actually, you must use the shift function and then find x power of negative 1. You should be able to see the factorial. So now, this expansion is valid for the modulus of x less than 1. So that means if you open the modulus sign, it means that x should be in between negative 1 until 1. So this expansion is valid for or some. So what does it mean? That means if we substitute the value of x in between this number, the value on the left hand side will be equal to the right hand side. So nilai dia akan sama kiri dengan kanan. Andai kata ax di antara negatif 1 sampai 1. Lupa nama dia apa. Di antara, in between. So if ax is in between negative 1 and 1, if you substitute on the left hand side and right hand side, you are going to get a similar number. If the value of x outside of this expansion, so that means if you substitute on the left hand side, it wouldn't be equal to the right hand side. Dia tak boleh sama lah kiri dengan kanan sebab dia tak masuk dalam validity punya expansion. So kalau kita ganti, kita tak akan dapat nilai yang sama. Boleh dapat ke konsep tu? Do you get the concept? What do we mean by validity over here? Is that if you have some value of x in between negative 1 until 1, so that means if you substitute the value of x on the left hand side and you substitute the value of x on the right hand side, it should be equal. Otherwise, it won't be equal. Okay, now let's go to the next example. Example 3. So expand 1 plus 3x to the power of 1 over 3 in ascending powers of x until n including the term x cubed. And then after we expand them, we got to substitute x equal to 1 over 1 to 5. Find the value for cubic root of 2, cube root of 2 to 5 decimal places. Okay, so there are a few crucial things over here. So we should expand up until x cubed. So they actually should tell us until when should we expand them, because if you refer to the formula, we actually have the plus dot dot dot. So that means we can keep on continue until x to the power of 4, x to the power of 5, x to the power of 6 and so on. So they should let us know when to stop. So from here, we should include up until x cubed. So that means we will stop up until x cubed. And then one more crucial thing is that when we substitute, as you can see, we have 5 decimal places over here. So that means for our working, we should work with 5 plus 1. So 6 decimal places and give our final answer in 5 decimal places. So the working step should be at least one more compared to the final answer. So kalau final nak 5 decimal places, working kita kena 6 lah, kena lebih sikit sebab dia masa tengah working. So I'll show you later on what do I mean by working and the final answer. Okay, so now let us expand 1 plus 3x to the power of 1 over 3. Okay, so compare with the formula. So this number is already 1. So that means I can directly use the formula. If the number is not 1, I should factorize them first. And then ax, so ax is simply 3x. And then n, that is simply 1 over 3. Okay, so 1 is 1, 3x is ax, and then n is simply 1 over 3. So substitute into the formula. 1 plus n times with ax. So this is n ax. So 1 over 3 times with 3x plus. So this is n minus 1 over 2 factorial, and then this is ax square plus n minus 1, n minus 2 over 3 factorial, 3x cubed plus dot dot dot. So we should always have this plus dot 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 because this expansion keep on going until x to the power of 4, x to the power of 5 and so on. So we should always write down plus dot dot dot. So do make sure to write this in your calculation. Okay, so now we are going to use our calculator to simplify them. But do be very careful over here. We have 3x and then square. So that means 3 square x square. This is 3x cube. So 3 cube x cube. So do simplify one by one. So the first one is 1. Second one, simplify them. You should get x. Simplify the next one, you should get negative x squared. Simplify the next one, that should be 5 over 3 x cubed and then plus dot dot dot. So again, we keep on writing down plus dot dot dot. Okay, so this is our expansion. So now let us answer the validity part. For the expansion to be valid, so we have to put the ax inside the modulus and let them to be less than 1. Okay, so ax is 3x, so the modulus of 3x will be less than 1. So that means x will be in between negative 1 over 3 and 1 over 3. So modulus of ax less than 1. So always refer to your ax. What is the value for ax? Okay, so now we got to substitute 1 over 1 to 5 on the left hand side and right hand side of the equation. So substitute on the left hand side. So on the left hand side we have 1 plus 3x, right? So this is 1 plus 3 times with 1 over 1 to 5. And then everything to the power of 1 over 3. Equal to, on the right hand side, every time you see the x, replace them with 1 over 1 to 5. So 1 plus 1 over 1 to 5 minus 1 over 1 to 5 square plus 5 over 3, 1 over 1 to 5 cube. And then of course plus dot dot dot. But since the number is very small, we can neglect them later on. Okay, so now on the left hand side, let us simplify them. So 1 to 5 over 1 to 5. So change the 1 into a fraction. So that is 1 to 5 over 1 to 5 plus 3 over 1 to 5. So we should simplify them later on. And then this one, simplify them. Okay, so this is 1 to 8 over 1 to 5 to the power of 1 over 3. So on the right hand side, we will use our calculator and find out the answer. And this is what I mean by the working should be greater than what we want. So if you refer to the question said give your final answer in 5 decimal places. If you look at this from the working, we have 1, 2, 3, 4, 5, 6. So this is what I mean by your working. For your working, you should have more decimal places compared to your final answer. So kalau final answer nak 5 decimal places, masa working kita kena pakai 6 lah. So this is what I mean. Okay, so now from the question, we don't want this actually. What do we want is the cube root of 2. So let us see how can we actually find out cube root of 2 from here. Okay, so 1 to 8 is actually 64 times with 2 over 1 to 5, and then let everything to the power of 1 over 3. And this is 1.007937. And then of course you should apply 1 over 3 for each of them. So it will be cube root of 64, cube root of 2, cube root of 1 to 5. And this is equal to 1.007937. Okay, so now the thing that we want is actually this one. So I'm going to leave them on the left hand side. Cube root of 64, let us find out this value first. And cube root of 1 to 5, let us find out this value first. And after that, I'm going to bring it to the right hand side. So cube root of 64 is actually 4. Cube root of 1 to 5 is actually 5. So let us bring the 4 and the 5 to the right hand side. So that means cube root of 2 is actually 5 over 4 times with 1.007937. So now the final answer is 1.25992, which is in 5 decimal places. So masa final answer baru kita bagi 5 decimal places lah. Masa working semua 6. Apa? Daus? Hi madam, kami kat Dewan. Madam RM2 dulu. Kat Dewan lah. Listen carefully. Dengarlah taklimat elok. Okay, so done with this. So let us go to the last example, I think. Example 4. So by using binomial expansion, expand 1 over 2 minus x square in ascending power of x until the term x cubed. So we got to expand first. Hence, state the range values of x for the expansion to be valid. And then B, find the value of 1.9 to the power of -2 correct to 3 decimal places. Okay, so the first thing that you should take note is that this one, 1 over 2 minus x to the power of 2, we should bring them up first. So change this to 2 minus x to the power of -2. And then we can expand them. But before you expand, another thing to take note or to handle is that the first digit is not 1. So that means we should, the first digit is, kalik lah tengok benda ni. Okay, the first digit is not 1, so you should factorize them first and then apply the power. And then after that, you can actually expand them. So do make sure to factorize this one first and then use the formula. So I'll give you 5 minutes for you to expand them mm, until X cube. So saya bagi masa 5 minit lah untuk awak expand. So cubalah expand. Oh Ashmil pun dengarlah betul-betul. Dengarlah taklimat. Tak start lagi. Awalnya. Oh wow, kertas dengan pen ke tu? Ke awak kira congak je dalam kepala? Kalau congak je dahsyat juga lah. So siapa yang dah dapat expansion bagi tahu Okay. Wah, 5 saat lagi. Siap dah ke? Macam tak siap lagi je. Macam dengar macam awak ada je. Sains. Isi je lah. Macam tak dapat lagi je. Saya tambah lagi 2 minit lah untuk expand. Okay, never mind. So now let us expand. Oh, this one dah dapat dah. Lama sikit kot sebab dia fraction kot saya rasa. Okay, tak apa. So if let's say you have expand, then you can check with me. If you haven't expand, then you can expand together with me, of course. Okay, so now let us expand. So we got 1 over 2 minus x squared. So I already told you guys that you should bring them up. So we are going to get 2 minus x to the power of negative 2. And then in order to use this formula, so instead of having 2, we should factorize the 2 outside. So we will have 2, 1 minus x over 2 to the power of negative 2. And then let us apply the power. So we will have 2 to the power of negative 2, 1 minus x over 2 to the power of negative 2. And then 2 to the power of negative 2, simplify them. So this is actually 1 over 2 square, so 1 over 4. And then 1 minus x over 2 to the power of negative 2. So now you can actually expand this. So once we expand them, then we can times them with 1 over 4. Okay, so let us go to expand 1 minus x over 2 to the power of negative 2. So use this formula. So n is equal to negative 2, ax will be negative x over 2. So be extra careful because we are handling some fraction over here. Be extra careful. Okay, so 1 over 4, 1 minus x over 2 to the power of negative 2. Do make sure to leave 1 over 4 outside first when you expand them. So 1 over 4 and then use the formula for this expansion. Okay, so this is 1 plus n ax. So n is negative 2, ax is negative x over 2, n minus 1, 2 factorial, and then ax square, and n minus 1, n minus 2, 3 factorial, and then this is ax cubed. Okay, so I do feel that it will be better if, let's say, you do have something with a square over here. It will be easier if you separate the number and the x. So for me, I prefer to write them down as negative 1 over 2 square x square. And for this one, negative 1 over 2 cube x cube. So it will be much more easier for me when I want to multiply them. So I prefer to write them down like this. But of course, you can handle them whatever way that you learned before, or you can actually expand them first. So that is actually up to you. So for me, I prefer to separate them and then I simply use my calculator afterwards. But of course, you can actually square them. So negative x square, 2 square, so 4. Negative x, you cube them, so it will become negative x cube, 2 cube, so it will become 8. So up to you. Okay, so now we should simplify them after that. So it will become 1 plus x over 2 plus 3 over 4x squared plus 1 over 2 x cubed plus dot dot dot. So now we should multiply them with 1 over 4. So don't forget you have to write down 1 over 4 for each of them. So now let us times them in. So setiap satu term kena darab So ada 4 term kat dalam ni, kita darab dengan 4 sekali. So multiply with everything. So you are going to get 1 over 4 plus 1 over 4x plus 3 over 16x square plus 1 over 8x cubed. Pam. Betul lah. So Ahi punya betul. So Ahi boleh buat sini. Okay, done. So now. So this is actually how you want to write down your answer. So this is our final answer. Okay, so the validity, the modulus of 1 over 2x is less than 1. So open the modulus sign. So you are going to get 1 over 2x in between negative 1 and 1. So of course, bring the 2. 2 is simply a positive number. So I can actually times everything with 2. So times 2 on the left hand side, times 2 over here, times 2 over here. So we are going to get x in between negative 2 and 2. So now, from the question, we actually want to find out 1.9 to the power of negative 2. So from the question, we have 2 minus x to the power of negative 2. So that means if I want to get 1.9, then it should be 2 minus 0.1. So how do I know this is 2? Because this is 2 over here. So this is definitely 2. So 2 minus 0.1 to the power of negative 2. And then if you do check, 0.1 is actually inside the validity or inside the expansion valid for x in between negative 2 and 2. So that means we can definitely use 0.1. So kalau kata kita nak ganti apa-apa nilai, pastikan nombor tu berada dalam validity. Contohnya sekarang, the value for x is 0.1, right? So that is why I know I can use 0.1 because 0.1 is actually in between negative 2 and 2. Okay, so go back to your expansion. So every time you see the x, replace them with 0.1. So you're going to get 1 over 4 plus 1 over 0, 9, 3 over 16, 0.1 square, 1 over 8, 0.1 cube, and dot dot dot. So of course, later on, simply use your calculator and you should be able to get 0.277. And I do think that is the end of this lecture. Yep, no more slide. Okay, so that's the end for this lecture. So starting from next week, we are going to start with a new chapter called the matrices and system of linear equation. So we are going to learn how to add matrices minus and then how to multiply, how to find the determinant, minor, cofactor, and so on. So I'll see you guys next week in lecture. Bye everyone. Have a nice day. Good night. So untuk yang tengah dengar taklimat, selamat mendengar taklimat. Bye everyone. Sabar je lah.